Can I lose control?
Good afternoon. I'm waiting for students to animate. We are only that students. Yeah.
Okay. Yeah, you're clear. You're clear. You're okay.
Mm. We have to wait for students. Managing three. Wameingia ni 47. Mtafanya ndio wanasikia. Okay, good afternoon from TUS. Today being on Friday, on Friday last week, we were learning about the surface area of a frustum of a cone, frustum of a filament. We also learned about the volume of a frustum of a solid, and also frustum of a filament, volume of the frustum of a cone. So today I will start with the surface area of a sphere and then the volume of the sphere. We will do two examples on the same, and then after that you'll do a question combining the frustum of a cone, a sphere, or an hemisphere. So the surface area of a sphere. How do we get the surface area of a sphere? We said there's 4 pi r squared. That is the surface area of a sphere. 4 pi r squared. The surface area of hemisphere is supposed to be half of the sphere. The surface area of a hemisphere is supposed to be a half of the sphere, which is 2 pi r squared. That hemisphere is supposed to be a hollow hemisphere. But when you are told that the hemisphere is a solid, what are you supposed to do to get the area of that hemisphere? we said there is the 2 pi r squared plus the surface plus the area of the top surface. So it's supposed to be 2 pi r squared plus pi r squared. I'll repeat. If a hemisphere is a solid, for example, when you cut as an orange, you find that an orange, the hemisphere is occupied by a substance, and then the top is a circular part. So what we do, we have the area of the hemisphere, which is 2 pi r squared plus pi r squared, the area of the surface of the circular part of the hemisphere. So the area of a solid hemisphere is supposed to be 3 pi r squared. 3 pi r squared. The volume of a sphere. The volume of a sphere is supposed to be 4 pi r cubed, because the height of that sphere will be the radius of the same sphere. That is why you have 4 pi r cubed, then you divide it by 3. So it's supposed to be 4 over 3 pi r cubed. The volume of hemisphere is supposed to be 2 over 3 pi r cubed. 2 over 3 pi r cubed. For the sake of the ones who are joining us late, I'll repeat. Today we are supposed to start by learning the how to use the formula of getting the area of the sphere, the surface area of hemisphere, the volume of the sphere, and the volume of hemisphere. So you have said that the surface area of the sphere is 4 pi r squared. The surface area of hemisphere is supposed to be 2 pi r squared. But if the sphere is a solid, if this sphere is a solid, we are supposed to say it is the 2 pi r squared plus the circular part of the sphere, which is pi r squared. So it will be 3 pi r squared. 3 pi r squared. Then we have the volume of the sphere. The volume of the sphere will be 4 over 3 pi r cubed. That is the height of the sphere is supposed to be the radius of that sphere. So it's supposed to be 4 over 3 pi r cubed. The volume of the hemisphere will be a half of the volume of the sphere, which is 2 over 3 pi r cubed. And for this from Tuesdays, nobody is supposed to fail because the formulas are in your mathematical for figure. Mathematics for figure, the formulas are there. So you're supposed to check before you write that formula of yours, you're supposed to check whether you are correct, because some forget the term, variable. So I'll share on the screen the examples. Before I share, there's a technical issue. I'll give you the question. The first question, calculate to the nearest, before we wait for the error to be corrected, calculate to the nearest whole number the volume of a sphere of radius 6.3 centimeter. Calculate to the nearest whole number the volume of a sphere of radius 6.3 centimeters. Calculate the nearest whole number the volume of a sphere of radius 6.3 centimeters. 3 minutes. In fact, it is 2 minutes because you have a calculator. I'm kind of mistake. I started with the school. There's a mistake. Alvin, can't you? Alvin, can't you? What is the volume of this sphere?
Uh, 1047.82.
Is correct. Which pi have you used?
22/7.
Read the question. The question you have said, to the nearest whole number. To the nearest whole
1000
number.
1047.
Are you sure you have used 22/7?
Yes.
You have said it 4/3 times 22/7 times 6.3 cubed.
Yes.
Is it 48 or 47?
48.
I want this to be clear. Is it 48 or 47? If you have used 22/7. So
It's
there's 1048 centimeter cubed. So the error there is, instead of you adding 1, you have truncated. Though you have not, truncating is just leaving it without adding 1 or checking the next number that is 5 or greater than 5 or less than 5, so that you can check whether you are going to add or not to add. So that is the area whereby students lose marks. One, you give the answers 1047 point something without giving the answer as the nearest whole number. That is where we make mistakes. And if you can rectify those mistakes, unless the student rectifying by himself, the teacher cannot assist. So when you answer, when you are after calculation, you're supposed to check the question again and see whether there is any further instruction given. Next question. Calculate the nearest whole number, the volume of an hemispherical dam of radius 7 centimeter. Calculate to the nearest whole number, the volume of a hemispherical dam of radius 7 centimeters. Hemispherical dam of radius 7 centimeter. Here I'm giving you only 2 minutes. Anybody can press in. Who is this? Warren. Warren Kiprono. Warren,
Yes.
is what is your answer?
And 19 centimeters cube.
Pardon?
719 centimeters cube.
Yes, 719 centimeter cubed. Next question is on the surface of the surface area of a sphere. Calculate the surface area of a sphere. Calculate the surface area of a sphere of radius 14 centimeters. 2 minutes. Calculate the surface area of a sphere of radius 14 centimeters. Ian Ruto, Ian Rano. Ian Rano. Rana, Ian. Ian Rana, you have a question?
Change in the first question, did you say the answer is 1047 centimeters cube or 1048?
It's 1048 to the nearest whole number. The answer is supposed to be, the first one is you are supposed to get 1047 point something.
Yeah.
Together. Then you round off to the nearest whole number.
Okay. Thank you.
1048.
Thank you.
Is it clear?
Yes.
Okay. There was another question. Mutuma. Iya Rana. Tumeshamaliza. Okay. Nataka swali. Okay, I'll repeat the question. Calculate the surface area of a sphere of radius 14 centimeters. Calculate the surface area of a sphere of radius 14 centimeters. Surface. In fact, the ones that we started with. Hiyo. Hiyo tumeshafanya. The surface wengine. Hiyo tumefanya ya poli. Sasa nauliza hiyo mwapia anza kuta hiyo. Mm. Atakuwa ndio msafi. Ndio na kwa hiyo safi stereo ba. Maana wengine iko na ansa ndio hiyo. Haikaenda. Ifute tu. You can speak to it to display at kitabu. Ili. Msuri. Hiyo namba hata ungekata. Nimechoka wanaitafuta kwa kliniki wanatupea nje. Tembea mimi tu atupea ansa. Mtu aniupi. Jonathan Kibe. Jonathan,
Yes,
what is your answer?
2,464 centimeters squared.
Yes, very good. And next, if there is a question, I have to allow me to continue. The fourth question, calculate the total surface area of a hemisphere of radius 7 centimeters. Calculate the total surface area of a hemisphere. Calculate the total surface area of a solid hemisphere of radius 7 centimeters. Calculate the total surface area of a hemisphere of radius 7 centimeters. I've said you calculate the total surface area of a hemisphere of radius 7 centimeters. Motuma, what is the answer?
308 centimeters squared.
308. What have you done to get 308?
I've done 2 pi r squared, which is the formula for getting the total surface area of a hemisphere.
Have you added the top?
Oh, no.
Get the circular part because I said it's supposed to be the solid. I said the solid hemisphere of radius 7 centimeters. Always, when you're not told whether it is a solid or all, you're supposed to add that part, the top part. Is it okay? Yes. So when you add, what do you get? Austin. The hand of this one. Insert again.
461.87 centimeters squared.
To the whole, which pi have you used?
3.142.
Yes. And if you use 22/7, what do you get? Any other
I-
student area? Yes? Areas, I'm still with the areas. Areas?
I have got 460.
Yes, be clear, please. It's not clear. And Mkeru? And Mkeru? Ernest Mumo? Ernest Mumo, what is your answer? Ernest Mumo? I'm not answering. Eh? Dennis. Dennis ni mwanimut. Dennis
462 centimeters squared.
Yeah, to the whole number is 462. You have 2% to the whole number. You can also use 3.142 because the pi is not given. If you are not given any pi, you can use 22/7 or 3.142. When I was marking your last papers, I saw some students were using 3.41. I don't know who gave them that figure. So always use 4 significant figures when you are working with a pi. Now I have a question on the screen. There's a question on the screen on the application of the surface area of a sphere, a cone, and a frustum. Is that clear? There is a question on the screen. Muma, is that clear?
Yes.
Is the question clear?
Yes.
Okay, continue. I'm giving you 10 minutes. It's a question of 10 marks. So I'm timing you is 10 minutes. Andro? Ephraim, you have a question?
An answer. I have an answer.
Ephraim? Yes, give us.
The area of the hemispherical surface is 7,700. The slant height of the cone from which the frustum was cut is 100 centimeters. And the total surface area is 17,556 centimeters squared.
Now, what have you done to get the answer?
The area of the hemispherical surface, I took 2 pi r squared because it only covers half of a hemisphere. And then I got 7,700 centimeters squared. And then I used similarity and enlargement to get the total slant height. 70 over 28 is equals to 60 plus x over x, and I substituted to get 100 centimeters. And then
Excuse me.
Yes.
What was the value of x? Please, can you move step by step so
X,
that everybody can understand what you have done? Move
X
step
is
by
40 X is 40 centimeters.
and you took x as what? What was your
X
x?
40 centimeters.
Excuse me. That
Yes,
40 centimeter is which height? Is it the height of the frustum or the height of? Can you specify that x
it
was
is the
for?
height of the other small cone that when you extend this frustum, the cone that was cut, that the slant height of the cone is x.
Yes.
So when I substituted 70 diameter of the bigger diameter of the smaller diameter is equals to the total slant height over the height of the slant height of the small cone, which is 70 over 28 will give us 60 plus x over x. Then 70 over 28, substitute by 7, you get 10 over 4. When then you take 4 times 60 plus x is equals to 10 times x. Then you get 240 plus 4x is equals to 10x. 4x to the other side you subtract, you get 240. 240 is equals to 6x. Then you substitute, you get 40 is equals to x. So 40 is the slant height of the smaller cone. Then I add 40 to 60 to get the total slant height of the cone,
Yes.
which is
Continue.
100 centimeters.
Very good. That was explained very well. Next.
Then when we are getting the total surface area, we are reminded that this object is a solid. So the area of the area of the circle here below will also count. So we are going to add the area of the hemisphere and the area of the frustum plus the area of the circle here. Then we take the area of the hemisphere, which here we have gotten 7,700 centimeters squared, plus the area of this cone of this frustum. So first we get the area of the larger cone, we subtract from the area of the smaller cone, which will be 22 over 7 times pi. The formula for getting the area of a cone is pi RL, which is 22 over 7 times the radius of the bigger diameter is 35. 22 over 7 times 35 times 100, which is the slant height of the total cone, to get 11,000. Then you subtract from the area of the smaller cone, which is 22 over 7 times 14 times 40, to get 1,760. You subtract to get 9,240. Then you add to 7,700, but before that we get the area of the circle here below, pi r squared, 22 over 7 times 14 times 14, to get 616. Then we add all of them together, we get 17,556 centimeters squared.
Yes, very good. But I have this to make correction. Please let me make this correction. You have said that the area, the area of a cone is pi RL. But that one is the area of which part?
Of the curved surface.
Yes, so you're supposed to use the curved surface. That's all.
Yes.
Okay, then the other thing is I've said with some students using, because this question we are using the pi RL, we are using the pi R squared. You find that a student uses in the part A 22 over 7. The part B used 22/7, but part C used 3.142. That one, there is an error there. If you have a question that is using pi, we use only one type of pi throughout. Don't mix the pies. Is that clear?
Yes.
Yes. Now let's continue. Unless if a student has a question on that area, please, if you have a question, ask.
Excuse me, Cha.
Yes.
How do you find the slant height of the bigger cone? I did not understand there.
Okay, how to get the slant height of the main?
Yeah.
Is it, it's supposed to be there. We are supposed to use the similarity. Remember, the similarity is the limit factor. Remember, we have the ratio of corresponding sides. And the ratio of the corresponding sides that we have the radius of the bigger cone, and we have the radius of the smaller cone. Then we have the slant height of the bigger cone, which is supposed to be 60 plus x. It told us to take the height, the slant height, not the slant height, but the slant edge, the small cone to be x. So when we have the slant edge of the frustum to be 60, so the slant edge of the whole cone will be 60 plus x. So you're supposed to say 70/28 is equals 60 plus x over x. Then you work out for x. When you get x as 40, you add now 40 to 60, you get 100. Now the slant edge of the whole cone.
Thank you.
Another question, please. That one was Mark, Mitch. Another question?
Yes. I was asking how we got the area of the hemispherical surface.
Area of the hemisphere, we said it is 2 pi r squared. If it is, yes, it is a solid, but you can see the circular part now is joined with the other part of the cone. And you see this, we are having it is a joint, it's a continuous. So
yes.
you don't add pi r squared. So you have only 2 pi r squared.
So now, so if it's a solid, we do the 3 pi r squared.
Okay, if it is a solid, for example, when you cut an orange, you find that an orange has a circular part on top. So it is the area of the sphere, which is 4 pi r squared over 2, you get the which is 2 pi r squared plus pi r squared of the circular part. So you get the total as 3 pi r squared. But in this case, this solid is a continuous. You can see the circular part is a dotted part, meaning it is virtual. Is that clear?
Yes.
It is not true. The dotted line shows you that is a circular part which has this diameter. That one is to assist you to get the diameter of the cone, the bigger cone. So then you don't add that circular part because this is a solid and you cannot see inside. Is it clear? It's a continuous solid.
Yeah. Thank you.
Okay, another question. What is your question?
Yes.
Yes,
How do you
ask.
find the surface area of the slanted part of the cone?
The slant, the curved part.
Oh, the curved part.
Okay, the curved part we said it is the slant, the curved part of the whole cone minus the curved part of the small cone. That is pi RL, whereby the R is the capital, minus pi RL, where the other L now is the R is the small r, the radius of the small cone, the curved surface. And we say that when we are getting the surface area of a frustum, if it is a solid, we say the curved surface of the bigger cone minus the curved surface of the smaller cone plus the top and the bottom. Then if it is an open cup, for example, a lampshade is the one that is used to have the lamp inside the bulb. The lampshade is open on both sides, so you don't add the top and the bottom, the area of the circular part of the top and the bottom. You just add the area of the curved surface. Is that clear out there?
Yes.
Yes, yeah. RJ?
Sure. Could you repeat the answer for C?
C. The answer is 17,556 centimeters squared. 17,556 centimeters squared. Next question. The next question is there. Next question is there. 10 marks.
Maybe 5 minutes, 5 minutes each. I want to send them. Okay, let's see. Excuse me. Sound height. 15
They're
centimeters.
supposed to calculate the panel, that is the height. They're supposed to calculate.
Oh. You can share it over. So that I can arrange these things. Na hizi zimekuja sahi. So tuko question gani sahi?
Yeah.
This one will be okay. Sasa ingekuwa kitambo. Najua mtu akitaka kukula as a student unaweza isoma polepole.
Nifanya hapo bado.
Yeah.
There is an issue. BM. BM. Maybe I am not okay. I cannot give them a question and then they will do in the Zoom. That's why I cannot give them the question. They do. I'm supposed to explain the question. And I'm meeting. There's no problem. Okay, with the question we have, your 10 minutes are over. We are supposed to get the surface area, the curved surface of a cone. We get the area of the cylinder. Then we get the area of the hemisphere. After that, we add the area of the curved surface of the cone to the area of the curved surface of the cylinder to the area of the hemisphere. Alan Clinton, you can see English. Clinton?
Yes.
Yes.
You have been told to number 8 tells us that you get the external surface area of the model. So I started first getting the cone up there, and the cone to get the curved surface, because you have been told the external surface area, it means the curved surface. So the curved surface area of the cone is pi RL. So because we have been given the total height of this storage tank is 15 centimeters, and the cylinder itself has 8 centimeters, and the height of the hemisphere is 3 centimeters. You will take 8 plus 3, which is 11. Then 15 minus 11, it will be 4. So 4 is the height of the cone. So to get the slant edge of the cone, you will do Pythagoras theorem, and you get, because 4 is the height and 3 is the radius of that cone. So you get 5 as the L of the cone. So you'll do, to get the curved surface area of the cone, you'll do 3.142 times 3 times 5. Then you'll get 47.13. So then you get to the next step. You get the the curved surface area of the cylinder, which is pi dh. So you take 3.142 times 3 times 3 times 2, then you get 56.556. Sorry, that for you to get the surface area of the cylinder, you take 3.142 times 8 times 6. Then you'll get 150.816. To get the surface area of the hemisphere, you'll do 2 pi r squared, which is 2 times 3.142 times 3 times 3. Then you get 56.556. And when you add them, you'll get 254.5 centimeters squared. So then the next.
Yes.
Then the next one, you have been told that the actual storage container has a total height of 6 meters. And the outside of the actual storage tank is to be painted. So here you're asked about the linear scale factor and the area scale factor. So because area scale factor is equals to linear scale factor squared, you will do 15, which is the height of the model, 15 all over 600, which is the height. You take that 6 meters, you multiply by 100, it will be 600 centimeters. So it will be 15 all over 600. When you divide, it will be 1 all over 40. And because area scale factor is equal to linear scale factor squared, you take 1 all over 40, you square, you'll get 1 all over 1,600. Now, because you have now the area scale factor, you will take now the one you equate it with the model, the area of the model, which is 254.5. Then you'll get that 1600 times 254.5. Then you'll get 407,103.2 centimeters squared. That is now the area of the actual storage container. So when you want to get the paint that was used, you will say that if 20 meters squared is used to paint uses to 0.75 liters, what about the area of the actual storage tank? Then when you divide, you get 4. You'll get the answer as 1.5270 liters.
Very good. That is the answer. And let's see if there is a question. Let's see if there is a question. That he has done it very well. Any question? Next. We have the wedge. The diagram below represents a rectangular swimming pool of 25 meters long and 10 meters wide. The sides of the pool are vertical. The floor of the pool stands uniformly such that the depth of the shallow end is 1 meter and at the deep end is 2.8 meters. Calculate the volume of water required to completely fill the pool. Get the area, the volume of them, but we have to divide the trapezium part of it. We have to get the surface area of this side, which we have 25 and 2.8. That one you have to divide it so that you can have the triangle with 2.8 The triangle 0.8, a half times 1.8 times 25 plus the area of 1 centimeter or 1 meter by 25. Then you multiply by 10 meters so that you can get the volume. So I'm giving you also 10 minutes to do the question. Remember, the volume of this shape will be the surface area multiplied by the height. The surface area on this face that look like a trapezium and is not a trapezium, because the shape is the same as the one at the other side. So you divide that shape to get a triangle and a rectangle. A triangle of base 1.8 and a height of 25, then the rectangle of 1 meter by 25. Then after that, you add the two areas, then you multiply by 10 to get the volume of that pool. Ian Rana. Ndil ndoe. Ndil. Ndil. Ian Rana.
So I found the answer for A. I found the answer for A.
And then you explain how you
I've gotten the answer is 475 meters cubic.
Yes.
So I first of all divided the shape which looks like a trapezium to get a cuboid and somehow triangle, which is I found the rectangle and the triangle. So the rectangle had a length of 25 meters and a width of 1 meter. So 25 multiplied by 1, you get 25 meters squared. And then for the triangle, you have the base as 1.8 meters because the width of the rectangle is 1 meter. So 1 meter, 2.8 meters minus 1 meter, you remain with 1.8 meters. So 1.8 meters is the base and the height is 25 meters. So we find the area, which is a half base times height, and that is a half multiplied by 1.8 multiplied by 25 meters. You get the answer is 22.5 meters squared. So 22.5 meters squared plus 25 meters squared, you get 47.5 meters squared. Multiplied by the question says the diagram represents a rectangular swimming pool which is 25 meters long and 10 meters wide. So 47.5 meters squared multiplied by 10 meters to get the volume of the pool, you get 475 cubic meters.
Yes, correct. The next part will be one, the water is allowed in the pool at a constant rate through an inlet pipe for 9 hours for the water to just cover the entire floor of the pool. Calculate first the volume of the water that just covers the floor of the pool. So on the surface area, we have two object surfaces, that is for the rectangular one which give us a cuboid, and then the triangular one that give us the triangular prism. So for the, when we divide that face into two figures, you find that the lower one is the triangular one. So we are supposed to get a half times height times base, 10 times 10 to get the volume of that triangular part. So what is the answer? That one is already you have done in part A. So the answer is there. Alan Maina. Alan Maina. Ernest? Ernest?
This is what I've gotten as my, okay. The B Roman 1, that is the volume of water that just covers the floor of the pool. This is what I've done. Since it is a trapezium, it's a trapezium and it has only covered the floor of the pool. You'll draw the cross-sectional area, that is the trapezium, and then look at only the part that will be covered. It will form something like a triangle, and its dimensions will be a height of 1.8 meters and its length as 25 meters. And so you'll get the cross-sectional area of the, okay, you'll find the area of the triangle that is using its formula, half times base times height. And I did that and I found 22.5 meters squared, and then you multiply it by the length, that is 10 meters. You'll get to 225 meters cubed.
Yes, it is correct.
Roman B, do you continue?
Yes. Roman 2.
Roman 2, the time needed to completely fill the remaining part of the pool. Now, the only part that is remaining now is, okay, you can use the answer you have gotten in question, okay, in number 4A. That is the total volume of the pool, which is 475 meters cubed. So you'll take 475 meters cubed minus 225 meters cubed. You'll find the answer as 250 meters cubed. And so you'll equate it to, if 9 hours, okay, if 225 meters cubed can be filled within 9 hours, what about 250 meters cubed? And the answer you'll get is 10 hours.
Yeah, it is correct. Any other question? Any question on that part of the pool? There's a question I've given you. So I'm giving now the questions. You write this question. Okay. After 5 minutes, put this and then we are done. I want to explain this when it comes. Okay. Okay, this question is the assignment. You copy it. I have 3 questions for assignment. Next. The 2 questions. Do you have the next 2 questions? Okay, as you copy the questions, I think now you are through the surface area, perimeter, surface area of the solids, prisms, and the shapes that we have. Then we have the volume of the same shapes. So unless a student have a question, we are done with that topic. So the next lesson, we are going to start a new topic. Then for more work to be done, to do, for practice, we use KMF, that is Mathematics Made Familiar, KCSE Made Familiar. Topic 15. Topic 15 on measurement. The 15.1 covers perimeter, which we covered in Form 1. 15.2 covers area in Form 1 and 2. That is surface area. And then 15.3 covers volume in Form 1 and 2. 15.4 covers density. Density we covered in Form 1. And remember, density is volume, is mass over volume. So volume we cover, some volume we cover in, some part of the volume we cover in Form 2, combined with the surface area. And then 15.5 we have time, and time we cover in Form 1. So unless if you have a question, I wish you a good weekend. What is raising hand? Is a hand raised here? You understand?
So can you kindly show the first question? Not the one for the assignment. Yeah.
Yeah, it is. Yeah, let me work on it.
Thank you. Iko sawa.
Good student.
Rudisha hiyo question ya kwanza.
Yes. Can you screenshot your assignment? Enda mimi kwa hiyo ingine, I think ukiona wanasema hiyo ingine mingi vya tano. Nyinyi akajua. Sasa the licenses are the news. That's one. If there is no other question, I will end the lesson. Have a good weekend.